Varma from National Institute of Technology, Bhimvaram, ECE branch. Now I am explaining about the topic is engram from artificial intelligence. Now I am saying about the topic is engram. Engram is probably the easiest concept to understand in the whole machine learning space. I guess an engram means a sequence of words. So for example, medium blog is a 2 gram, a bigram, a medium blog post is a 4 gram, and right hand medium is a 3 gram trigram. Well, that was not very interesting or exciting, true, but we still have to look at the probability used with n-grams, which is quite interesting. And then the n-gram model, like many statistical models, is a significantly dependent on the training corrupts the n-gram model, like many statistical models, is significantly dependent on the training corrupts. As a result, the probabilities often encode particular facts about a given training corrupts. Besides the performance of Besides, the performances of n-gram model varies with the change in the value of n. Moreover, you may have a language task in which you know all the words that can occur, and hence we know the vocabulary size v in advance. The idea is to use tokens such as bigrams in future space instead of just unigrams. And another part in the n-gram is n-gram probabilities. Let's take the example of a sentence completion system, which could be used next in a given sentence. Suppose I give the sentence, "Thank you so much for your work," is an explanatory, and expect the system to predict what the next word is help with a very high probability. And the thing is, one important thing to note here is that as for any other artificial intelligence or machine learning model, we need to train the model with a huge corpus of data. Another part of the engram is smoothing. In this smoothing, a notable problem with the MLE approach is sparse data, meaning any engram that appeared a sufficient number of times might have a reasonable estimate for its probability, but because any corpus is limited, some perfectly acceptable English word sequences are bound to be missing from it. But because any corpus is limited, some perfectly acceptable English word sequences are. As a result of it, the n-gram matrix for any training corpus is bound to have a sustainable number of cases of putative zero probability.
Hi, this is Monika studying first BTech. In this video, I would like to discuss bag of words. We know that bag of words, n-gram, one-hot encoding, term frequency, inverse document frequency are the steps to get text data into workable format in natural language processing. In this video, I would like to explain clearly about bag of words. We know that bag of words is a two-step process. The first step is a vocabulary of known words, and second step is a measure of the presence of known words. Bag of words is a simplest and easiest representation of textual information used in natural language processing. In bag of words, only some set of words are considered, and the order of words and grammar is not taken into consideration. It is the popular feature extraction method in natural language processing. In the first step, all the unique words in the document or text is collected. For example, treat each line as separate document. Here we have 4 lines called document 1, document 2, document 3 and document 4. The first document is "It was the best of times" and "best of wisdom." Second one is "It was the best and worst of times." Third document is "It was the age of wisdom." Fourth document is "It was the age of foolishness." Let us collect all the unique words in the text or document. The first we collect by applying tokenization technique. In this tokenization technique, each text or each document or sentence is divided into separate words, and we collect all the unique words from our corpus. Corpus is nothing but collection of documents. We gather these unique words. It was, the, best, of, times, worst, is, wisdom, and foolishness. These are the unique words in our document. This is the second step in the bag of words. Now we will have a table where column corresponds to the index of unique words and rows corresponds to the number of times a word occurs in a document. Here it has index 1, was has index 2, the has index 3, beast has index 4, of has index 5, and so on. And rows corresponds to the number of times a word occurs in a document. This results in a vector with lots of zero scores called a space vector or space representation. Space vector requires more money and computational resources when modeling, and the vast number of positions or dimensions can make the modeling process very challenging for traditional algorithms. In order to reduce the size of this table, we need to use the techniques like stopwords removal, stemming, lemmatization, and then we apply bag of words. Let me explain about stopwords removal. It is a process of removing common language articles, pronouns, and prepositions such as an, the, or to in English. These words provide little or no value to natural language processing. Such stopwords are removed or filtered from text for better efficiency. And another technique is stemming and lemmatization. Coming to stemming, it is a rule-based process of stripping the suffixes like ing, ly, es, and s from a word. Stemming uses algorithm approaches. The result of the stemming process may not be an actual word or even change the word sometimes. To offset this effect, you can edit those predefined methods by adding or removing suffixes and rules. Stemming are simple use. It is a rule-based process of stripping the suffixes like ing, ly, es, s from a word. Stemming uses algorithm approaches. The result of the stemming process may not be an actual word or even change the word sometimes. To offset this effect, you can edit those predefined methods by adding or removing suffixes and rules. Stemmers are simple to use and run very fast, and its speed and performance are very important in natural language processing model. Then stemming is certainly the way to go. After applying stemming, the output look like, for example, consider a word called studying. After applying stemming, the word becomes study. In this studying word, it removes ing. Like that, it removes suffixes from the word. And other step is lemmatization. It is a organized and step-by-step procedure of obtaining the root from the word. It makes use of vocabulary and morphological analysis. Through this seems closely related to the stemming process, but lemmatization uses dictionary and it makes the word more effective, and it gathers the exact meaning of the word. For example, consider a word caring. After applying lemmatization, it becomes care. But in stemming, if we apply stemming to the caring word, it becomes car. It removes ing. But here we didn't get the actual meaning of the word. So, lemmatization is very useful in natural language processing. And by applying these techniques, we get the exact meaning of the text. Now, let us see what our table will become if we apply these techniques. After applying stemming, lemmatization, and stopwords removal techniques to the previous table, we get this table. This table contains less number of columns with compared to the previous table. And compare now different sentences to calculate the Euclidean distance between two different documents. And also check if two sentences are similar or not. If there would be no common words, distance would be much larger and vice versa. For example, here consider two documents, say D1 and D2. Calculate the Euclidean distance. 1 minus 2 square, 1 minus 1 square, like that. At the end, we get the output like 1.73. Like that, find the distance between other documents D1, D3, D1, D4, and so on. We get the result or output at the end of the process. And if the distance is less, our words are very similar and our documents are very similar. If the distance is large, our documents are not related to each other. With this technique, we can find the relation between the documents. Thank you.
Hi friends, I'm Surya of Vishnu Engineering College studying first BTech. Today I'm here to explain about Ngram. Hi friends, today I'm here to explain about Ngram. Ngram. Coming to its definition, we have so many types of definitions, and coming to the first one, in case Ngram. Ngram is one way to help machines understand a word in its context for better understanding of meaning of a word. It means that engrams help the machine to for clear understanding of the meaning of a word, and engrams are basically a set of co-occurring words within a given window, and when computing engrams you typically move one word forward. Co-occurring words means when we have to say thank you, then thank is one word and you is another word. So engram helps to calculate the probability of the word you after the word thank. And an engram model is a type of probabilistic language model for predicting next item in such a sequence in the form of an n-1 order. And now we have the types of engrams. We have so many types of engrams, and basically the main types are unigram, bigram, and trigram, and likewise and so on. When n is equals to 1, it is referred as unigram, and when n is equals to 2, it is referred as bigram, and when n is equals to 3, it is referred as trigram. Let's for example, let's take the sentence, this is a sentence, be our example. Then if n is equals to 1 for a unigram, for n is equals to 1, the examples of unigrams are this and is and a comma sentence. And for a bigram, the examples are this is and is a and a sentence. And for trigram, this is a comma is a sentence are our examples. And let take another example. Let patient has evidence of macular degeneration be our example statement. Then the unigrams are patient comma has comma evidence comma of and macular and degeneration. Bigrams, our examples for bigrams are patient has evidence of macular degeneration. And example for trigrams, under the trigrams in the above sentence are patient has evidence of macular degeneration, has evidence of macular. Now let's see how we can use n-grams for prediction. N-grams also help make next word predictions. For example, say you have the partial sentence, please hand over, and then its next word is more likely to be any of test or assignment or exam paper, then next word being school. It means that when you can say please hand over your test, or please hand over your assignment, or please hand over your exam paper, then you could not say that please hand over your school. So n-grams help for next word predictions. It can also help to make spelling error corrections. Basically, an n-gram model predicts occurrence of a word based on occurrence of n-1 previous word. For example, to find probability of word u after the word thank, we can write this as probability of u by thank, which is a conditional probability. When items are words, n-gram may also be called as shingles. And the bag of words model is an orderless document representation. Only the counts of words matter. The n-gram model, as an alternative, can store this special information. Now we can see the applications of n-grams. We can see a lot of applications of n-grams, and mainly the applications are Google and Microsoft have developed a web scale n-gram models that can be used in variety of tasks such as spelling correction, word breaking, and etc. And now we can see that n-gram models are now widely used in probability, communication theory, data compression, and natural language processing mainly. And we can see the benefits of n-grams are simplicity and scalability. And now with a larger n, a model can store more context with a well understood space-time trade-off. And now more concisely, an n-gram model predicts xi of a word based on xi minus n minus 1 and so on up to xi minus 1. In terms of probability, this is probability of xi to xi n minus 1 and so on up to xi minus 1. In a simple n-gram language model, probability of a word can be described as categorical distribution. The assumption that probability of a word depends only on previous word is also known as Markov assumption. Markov models are the class of probabilistic models that we can predict the probability of some future unit without looking too far in the past. And now we can see the other things about n-grams. If x is equals to number of words in a given sentence k, then the number of n-grams for the sentence k would be n-grams k is equals to x minus n minus 1. And consider an n-gram where units are characters and text with a t characters. The space this n-gram requires is exponential, that is n of t minus 2 of n minus 1 plus summation of I is equals to 1 to n minus 1 of 2i, where n and t belongs to natural numbers. And in the fields of computational linguistics and probability, an n-gram is a contiguous sequence of n items.
Thank you, guys.
Thank you everyone. I hope this video gives a better understanding of the topic.
Thank you guys.